all for coming. What? Speak up! You cannot hear me! Okay, I will speak up. I'm not sure if I can do that, but anyway, thanks for coming here. And, well, yeah. Mikko will tell us about Fractio first, and then he will present his presentation. So let's welcome Mikko to the stage.
Hello, I am Mikko or Pekkis. Nobody calls me Mikko except my mother, so I'm not suggesting you either to call me Mikko. So yes, Pekkis is nice. So firstly, I'm going to talk 2 hours about Fractio and advertise the shit out of our company, and then I will give a 5-minute presentation. So yes, be prepared. Do you have your drinks? Because this is going to take a lot of time. Yeah, so basically I'm assuming that everybody knows what Fractio is because we are famous, world famous. But yeah, we build web applications with React. We love React. I think that we've been using React like heavily from 2014, and basically in all our projects we use that. Unless the projects are mobile applications, and then we are using React Native. So yeah, I am one of the founders of our noble company, and now we are 33. And yes, we need more coders. And if you come here and give us 7.5 hours of your time per day, we will give you money. And that is how working at Fractio will work. And it will be an indoor job with interesting projects and interesting co-workers and fair compensation and okay benefits and award-winning culture and a chance to grow with us, like physically, also mentally. Yes, we are looking for more people. And some practical information about today's event. 2 presentations first, then a break, and 1 more. And there is cola, pizza, and beer. Help yourselves and feel yourselves at home. And if you look beyond that door, you will see that we have a movie theater. We have not built it. It's the movie theater from the 50s, from the Finnish Movie Inspection Bureau. So it's a part of Finnish movie history. And we are not going to spoil it. And yeah, you can identify these Fractio people from the smell. So please go and talk to them if you want to know more about Fractio. Yeah, so there's actually nothing more about Fractio. And I was aiming to do my presentations like last and to hear like the rest of the guys and then like improvise. But now I'm in the situation that I have to do it first. So I have nothing to prepare myself. So yeah, what I was or am going to talk about are these Redux Sagas. And of course, first I want to ask you a question. Who has used these magical Redux Sagas? What do you think? Do you like it?
Not anymore.
Not anymore. What is better?
Because it doesn't work great with TypeScript.
Well, I don't like TypeScript, so no problem for me. Yeah. Yeah. So, but anyways, okay. Another question. Who has used Redux? Well, some a little bit more. Okay. So, who has used React? So, yeah, basically, that's of course where we all started from. I found React back in 2014, and I think that it was the shit. I was like, whoa! For the first time, everything in the front end is making some sense. So I absolutely fell in love with React at first, and then I went through like maybe 10 of these different Flux libraries, and then I found Redux. And I kind of like fell in love with Redux too. I really like the way that Redux handles my state. So, but there's always like this tiny bit missing from Redux, that where does stuff belong? And one can pretty easily like show the point where you begin to wonder where that stuff is. Yeah, Vitali was talking about the trainings that we have. This is what I often end up after 2 days of like intensive training for professionals, we have this Fractio ERP application where I can do stuff with people. We always build in the first day, we build it with local state or like global state, and then in the second day we refactor it to Redux. And it works fantastically. You can see that if I open my Redux toolbar, there's some stuff going on that happens here. Yeah, get nice animations, by the way, with React Pose. I've been like teaching animations for like in 5 or 6 courses now, and I always get these totally random results. and this time I just like succeeded by accident with Pose, and I have no idea how it works and why, but I still achieved this animation. So yeah, so there's Fractio employees here. All the bad persons are like women or men over 30 years old, and they have to be kicked out. And then there's the good persons that are young males only, of course. So we have something that we discriminate them. Totally random stuff. And then when I liberate the guy, well, there's this nice spinner, and it will take a long time. There's artificial weight, and hopefully it will, yeah. Look at the animation, by the way. Look and see. Yeah, totally by accident. So, okay, but here is actually the point where it begins to like get a little bit odd. If I look at the code, you can see that, well, the server is just a mocked thingy, and maybe I can get this bigger so somebody can see something. So basically there's all these, let's see, for example, this person. So I have the basic constructs of everybody has probably seen the tung. So I get total freedom with these asynchronous things that I have here. So pending, fulfilled, and rejected, all by hand. Then I always teach that, hey, if you don't want to write those ugly thungs again and again, I give them the Redux promise middleware that gives me the same, exactly the same thing as one-liner. So these are basically the 2 things that I get to teach about these actions. You have the thung and you have some promise middleware that makes these things easy. And we don't ever get to the authentication part, for example, because in 2 days there's not just time. But what if somebody would now say, for example, that, hey, is this the server process? Yeah. So I have made this change here that if I just add this environment variable require login, true, and then I restart it, we can now see that I have this situation where my liberation doesn't work anymore because now it requires authentication, right? So I can't like fire anybody anymore. I can't like hire, it's the same thing. So now the question, this has like a basic JSON web token authentication. Where does that stuff go? I want to call the API. I want to set the stuff, the token in my local storage. If I have a basic Redux app, where does this stuff go? Where do you put it?
Login process.
I don't know, I use Axios, I just put it there.
Yeah, where do you put it?
In the Axios, the thing that makes request.
Yeah. So I have that stuff like here in the doc. Do you, by the way, use the docs? Who uses docs? You should. Everybody should use these docs. But anyway, this is probably where you can put it. I've oftentimes even put some stuff here in the reducer. Has somebody put like side effects to the reducer at any time? Nobody. I have. Hey, there's some hands. Of course you can. I can just like call my local storage set item here if I want. But it's of course you can't, because this function should be pure. So basically, if I want to do something, it goes to the service or it goes to the like thunk. I can't like fathom any other place. Does somebody have some other ideas? Where do you put this stuff? For example, where do I call the set local storage is set item? Where do you put it? Yeah? Hey, Aatu, where do you put it?
I'm only waiting for Tohtori, not for Farzad.
Yeah, Iiro.
You can call it before you call Redux render
Yeah?
in your index.
Store subscribe, or like for every change in the store with some throttling, say this to local state.
Yeah, maybe. It sounds pretty ugly. Any other ideas?
I think we are getting baited into saying sagas.
Yeah, I think that the idea of these sagas is that they say it like pretty plainly, that it's a library that aims to make application side effects, blah, 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 easier to manage, more efficient to execute, easy to test, blah, handling failures, blah, mental model, blah, 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 and lots of stuff. And basically, you can take everything out from everywhere and basically put them to these sagas. And that's the way that I've been at least going. And these sagas work with this magical generator stuff. Who has used generators? Who has used generators outside of sagas? Where do you use them? Give me some like concrete examples.
Interview.
Yeah, interview. Good one, good one. Yeah.
I've written like a text output engine that uses generators
Yeah.
to like feed.
Can you tell me what a generator is? I think that it's like the most hardest part of this whole saga thing is to like understand what the generator actually is.
It's like a function that can be like which execution can be paused.
Yeah, and what more?
And resumed.
Yeah, and something more, I think. It's also an
Iterable. Yeah.
iterable and iterator.
Yeah.
Iterator, yeah. So it's basically an iterator that its execution can stop. And then it can yield the flow of control to somebody else, and then they can just say that please resume. So the code, it just stops, and then in some magical way the code goes back there. So I think that it's a little as a concept it's somewhat like hard to grasp before you just like look at it and what it actually does. Hey, Mr. Doctor, please. You are talking. My concentration will break if you talk loudly.
Okay.
Thank you. So, yeah. So I built this test file. Basically, here's this generator function. So you mark it always up with this like function star, and then there's this generator function, and you can see that I'm yielding helluray, and then I'm saying that const poop is yield helluray, and then I'm console logging this poop. Siinä on paikka miksi et lauo, and then there's something that's commented out. But anyways, I construct this function here with the call to this function, and I can just console log it and say what it does. This I don't want to run yet because it's easier to look at it when there's I can't code like anymore. So yeah, let's see what it does. So at first I can see that it's just an object generator, and then Legrande poop, I don't know where that comes from. So, and then you can see that it follows the iterator principle, that it returns this object that has some value and then whether it's done. And when it's done, it begins to give undefined and true. And I can just go back to the, let's see, I know how to do this. Yes. Nice. So at first it's yielding hell array. And where is grande pupa?
The fourth line.
Ah, yeah, from there. So yeah, firstly it yields hell array. Why does it give me the grande pupa immediately? I don't understand my own code.
No one understands generators.
Yeah, but there's more. These are first. I'm not understanding. I even tested this one. Why do you give me that one? I'm taking you away. Let's see. Does somebody understand why it becomes why it shows immediately? Well, I don't. I don't even think that this gives me the same.
Console logs after all the generator nexts. Scroll down. Scroll down.
Down?
Oh yeah.
Console log after all the next calls.
Yeah, here is. Yeah, but I don't understand why it comes at that point. I mean the order. Why is it here?
Because you're console logging inside the generator.
Yeah, but
You're first collecting everything that the generator generates and then console logging.
True. Basic stuff.
ah, yeah. That is true. Yeah. Yes.
But we have drums.
Yeah, but anyways, I'm just taking that out. But you can see that when I get the generator, I can just like get the next value, and then when I call the next with this le grande pupa, you can see that when I give the control back to the generator, it assigns it to that variable. So that's the magical thing, that I can send stuff back and the execution will stop. And yeah, and that's basically it. It's just the eternal iterator with this yielding stuff. And if I yield this array, taivas varille, mitä sieltä tulee, on se sellainen häkki. You can see that, so it's just yielding the value as an array, nothing magical there. But if I want to like yield the control to another generator or another iterator, I can also say that yield with this star, and then it will yield the control to that iterator or another generator and yield them one by one. So now it's just yielding all these taivas varille, mitä sieltä tulee, one at a time. So if you see this yield star syntax that I always keep seeing in my Saga thing, is I have basically never used it because I can achieve the same results with something else, but this is what it does. It just like says that you yield your stuff now and then I'm going to continue. So that is that. So basically I think that async and await are built on top of these generators, and that's how they work. And even if you are using Babel to like transpile for Internet Explorer 11, it's going to use this regenerator runtime thingy that allows it to work with Internet Explorer somehow. I have no understanding how it will work, but it will work. So if you're looking down a downside to these sagas and generators, Internet Explorer 11 doesn't support them at all, but it doesn't support async and await either, so I don't know. Who has to support Internet Explorer 11 like today? Do you have to support it with quotes or really support it? Like really, it has to be like 100% functional.
I also have to support Safari.
Yeah, but Safari is a little bit better, I think. A little bit, yeah. But yeah, I can feel your pain too. Yeah. So, but yeah, once you just like build a generator and look what it gives, then it I'm not saying that it becomes like totally obvious, but it becomes like understandable, I think. So yeah, so I've actually built some nice code in advance. So the actual, let's see, by the way, yeah, I think that I have this hell array here again, and the hell array becomes from, hey, don't be full screen anymore. So the hell array is becoming from here. Let's see. I have this client.js where my basic code is living. So here's just some abstractions that I have written. No details here. Anyway, somehow we get the store, and somehow we just added the Saga middleware to the stack of Redux middlewares, and then it's just a thing to say that please Saga middleware run this root Saga, and root Saga is coming from Saga's root, but there's nothing here for now. There's just this hell array, but now I can easily prove to you that code is at least executing, so we know that that's how you start the Saga. So you just say that run this root Saga, and then it's up to you. So I'm just going to check out head. Let's see. What is kuumottavaa in English? I mean, yeah, it's roasting to like code here live and 100 people are watching it. It's like, it's terrible. Let's see, what's today? Why are you like checkouting my head? Let's check out, it was, what's React? Yeah, now it's better. Let's see that something is happening. Let's see that yes. Now it's okay. So basically what I did, let's see. So I've augmented my application a little bit with these nice features. Now I have like a nice notification. I also have a login, and I have this, nothing is happening when I click these nice liberation buttons. So you can see that fire person is like dispatching, but nothing is happening. It's okay because I'm not logged in, so I don't want that stuff to happen. So basically with these sagas, what you can think is that you can just like model the workflow of your application like in paper, and then you can just implement it with these sagas. The saga is actually a good name for this concept because you can just like write these macro and micro operations that are asynchronous and hard to do, and you can just like write them and then sequence them and build like the saga of your application. And I think that it's really nice, and it comes handy in these cases if we think of the stuff that I want to do. I want to say that, hey, firstly, get all those persons, everybody can get the persons, and then give a nice warm welcoming message that must go away in 10 seconds, of course. You can see that it actually goes away. And then I want to like, hey, wait for somebody to log in. And when somebody successfully logs in, then start taking and doing stuff that only the signed up user can do. And then wait for logout and stop doing them. And you can think of these complex flows that you have to do something, then you have to do something activates. And at least for me, it's always like hard to think that how does one make these things in this event-based world. But you can think of it as such that you have this root saga. And of course, when you have a mental model of your application and you just model it, it doesn't like prevent your mental model being insane. And if your like idea of the stuff that how your software works is insane, it will still be insane. And I coded this tomorrow, and I'm beginning to think that it doesn't make any sense. But because my point is to like just show that how you can do this stuff, it's okay. It can be insane. So basically, we already saw this root saga, and it's as you can see, it's a generator. And when you are working with Redux Saga, you are always, or at least you should always, yield these effects from this Redux Saga. And the effect is just like an abstract way of saying that it will return. You can think of Redux actions. It returns a stupid object describing the stuff that I'm going to do. And of course, when you return these stupid things that don't actually do anything, then it's easy to test and reason with, because you don't have to mock any API calls. You are just going to like test that, hey, does this return an effect that is going to call some API? So it's pretty easy to test. So basically, it has all kinds of these effects: all, call, take, fork, take every, take leading, blah, blah, blah. Dr. Vesala here said that it reminded him of working in C. Or what did you say, like embedded systems or what? Yeah. So I have no idea, I have never coded these embedded systems. But anyways, all these effects that I can call. And then if you say, look at my root saga, you can say that, hey, just yield this all thingy, and all is it's just an effect that returns many other effects. So I'm going to say yield all, and I'm going to take the latest action that says get persons, and every time that I get this get persons, I'm going to call this get persons saga. And then I'm also going to yield this call to add notification, welcome to Fractio ERP 5000. And this notification is a good example, because it's another saga. It just takes a message and type information, and then it generates some UUID, and it yields this put thingy. And this put thingy is, it will, well, of course, you can probably see that this is an action. So it will dispatch an action to the Redux. So I'm just saying that, hey, yield this notification add with this payload, and then I'm going to spawn. And spawn means that just create an independent thread in my application, this auto dismissal one. And it will, like 7 seconds later, when it's yielded this delay, then it will call dismiss notification, and it will just put this notification dismiss. So nothing magical there. All the stuff is happening here in the sagas. And if you look at my reducers, for example, for this notification, there's nothing like weird there. Just handling these notification adds and notification dismisses. And here you can, by the way, see that my other library with Redux that I like always take and very much love is this immutable.js. Who is using immutable.js? It's a nice library. I always tend to like format my state inside Redux with immutable.js, because it gives me nice data structures and it gives me immutability. So a very good library. Yeah. So yeah. Why did you close? Sometimes I don't understand how VS Code is closing some files and then opening another one again, and it comes back. But yeah. So yield all these, and then spawn this initialize task. Initialize task is just saying that, hey, get the token from the local storage, the size effect is here, and then if I have a token, just log in with that token. Otherwise, I'm dispatching this stupid initialize task, and yeah, and then it does the, and yeah, again I closed it.
You need to double click to make it stay.
Yeah.
Do one.
Yeah. So basically, yeah, fork means that I'm forking this task, and this forking is like it's creating a subtask that I can cancel at any time. So basically, I'm saying that hey, fork this watch login, and that watch login goes to the background and starts waiting for that login stuff. Then it's moving on to even before this code executes, it moves here, and then I'm yielding arrays between these login success and login failure effects. That if somebody dispatches an action for login success or login failure, then it populates success or failure. And this doesn't make any sense. My flow is bad. But anyways, after this one, not depending whether it's a success or failure, I'm canceling this login task. Because now, hopefully, I've gotten the login success, and I'm not wanting to like listen to any more login attempts. I'm already inside. So let's cancel that. And if it's a success, I'm forking these logged in sagas, and it forks this one, and it begins to listen for these higher person and fire person events, and it then will delegate to this one, and it's also forking this watch efficient firing saga here. And yeah, and then again it moves on and it begins to wait for the logout. And when the logout happens, it's canceling all these logged in tasks, because now I can't fire people anymore, I'm logged out, right? And logged in sagas, this take every means that hey, get every time somebody is dispatching a higher person or fire person, just grab it and begin doing it. I can fire like 10 people at the same time. And this watch efficient firing is nice. You can say that I have this for loop here. From 1 to 3, I'm going to take these fire person fulfilled events, actions. And after that, I'm adding add notification. Excellent work, keep on firing these people. So every time this one comes, it like moves on from the loop, and basically what I should achieve from there is, let's say, login sukke. Now I see that I have a token. Let's liberate this one and that one and the third one. Let's see. It intensifies. Oh yeah. So you can see that my code is looking like really procedural and imperative, but actually it's doing these fancy things. And again, this code here is now stopped here. This take is nice. It's like pulling an action. The moment somebody dispatches this logout, the Redux saga will like give the control back here, and then something happens. And these while true loops are actually a nice construct here. Normally they would always cause like an infinite loop, but it doesn't work like that here, because when I get here, somebody will log out, I'm canceling the logged in task, and then again it goes here and begins to watch for the login, right? So the loop goes on, and I have implemented this nice complex flow where login must happen, then actions are allowed, and again logout until logout happens. So these complex flows where stuff must happen and then something activates, and you can yeah, they're pretty, I think, nice to implement here. And I'm not saying that it should come like a second nature in this 30 minutes, but I personally think that it's a nice way of doing basically everything. It's like, for me, it's been like the missing piece for my Redux application. And I can honestly say that for the like first 3 times or 4 times when I saw these sagas in some project, I think that they were implemented very badly, and you just have to like have this revelation where you just do stuff with them and like begin to think in a different like mindset. And for me, it was this project where I decided that I'm finally going to make remakes of these famous hockey manager simulations that I did back in the 90s and early 20s. And I wanted to do a remake, and I always had this problem where, because the code is from 1997, the original code, and it's like terrible. I learned coding to make these games, so basically it's terrible. It's so awful that you can't even like imagine it. But anyways, it's a turn-based game, and I always had this like block: how am I going to implement this turn-based logic easily within the scope of like these event-based web applications? And finally, with the sagas, I think that I cracked it. And when I cracked it and I implemented actually the whole first game of the trilogy already, it's not pretty, but all the actions are there, and basically the game is running, and it's all done with sagas, all the events and random events and answers to them, and everything is like working. So I think that this was a nice project where I feel that I understood how to use these sagas, and I think that together with Immutable.js and Redux, I think that it's the most sanest way by far until now to like construct these things. So I'm really just wanting to say that try it, learn it, and find the greatness in it. Do I have anything more? Questions? Yeah.
You only talked about the good stuff. What were the like pain points of using sagas? Were there any?
Well, my pain points, for example, so far have been like what to do with these goddamn actions. For example, because this has the side effect of like achieving the fact where all my actions are stupid. They don't have anything. They don't ever do anything. And so they become these the most stupid functions that just return the plain object. Should I, for example, like ditch them completely and just begin to dispatch actions like this and get rid of these action creators totally? That's been a mental pain point. What to make of them. But otherwise, I don't think that I've had any pain points, except of course the fact that when I began to do, I understood nothing, and I just like it's not that easy to grasp. But yeah, that's a mental pain point. What to do with that? What to do with these? Yeah.
Inquiring minds want to know: do you have any experience on converting Redux Funk projects to use Redux Sagas? Just asking.
Yeah, actually back and forth. We had this painfully badly done Redux Saga project that didn't need sagas, so we just took them out. And then yeah, I've done a few projects, yeah. So it's basically pretty straightforward, I think. Yeah, just ask tough questions. Yeah?
Thanks for your talk. It's really interesting. My question is, it seems like there's a lot of magic with Redux Sagas, maybe even Punk. How do you know that the Redux store is changing? How do you trace through that with your dev tools? Like, how can you understand that process, well, especially when there's like multiple steps in your side effect sequence?
Well, I don't think that there's actually nothing magical going on there, so that makes it like pretty easy to understand. I don't like say that I'm understanding what exactly the saga is doing, or how the middleware is like taking these and doing what it does. But in any case, it always just gets to the same logical point where all Redux applications go, that an action is dispatched, and then Redux handles the change, and there's nothing magical happening there, and that's the primary reason why I like Redux, is that even though there's something asynchronous going on somewhere, there's nothing asynchronous going on with Redux. It's just sequential sequence of these stupid actions and reducings, and there's nothing magical going on. So this doesn't change that.
Yeah, maybe if I could clarify. I mean, I'm quite far back, but what I see is you're pressing on buttons and sending off actions, and then the result, like, I'm not sure how that's happening. And if there were multiple things happening simultaneously or overlapping, I think that's where I'm not too sure, like, how you trace through that or understand that.
Oh yeah, basically my primary tool of trying to understand all these Redux applications is always this Redux dev tools. I think that they give me all the understanding that I need, because I see all the actions that happen. I see all the state after the changes. I can see the diffs between the state that the action is doing. So basically I think that this is a fantastic tool, and with it I can keep my sanity. This is pretty straightforward, I think. Of course the sagas themselves are not, but the dev tool is. Yeah.
Have you done any major projects with the reactive streams and observables?
I don't like them, so no. I have this problem with me that I'm a pretty mediocre developer, and I like my code to be understood by me and other mediocre developers. And I tend to think that every time you go to observables and reactive programming, it gets harder to understand. I think that the hammer with these sagas and with Redux is like more straightforward and understandable to me. I can understand why people use those, and I can understand why they are good, but I just think that they're much harder to grasp for me. I've done just like some playgrounds with MobX and stuff that's using observables, and of course the basic like playing with it, but nothing more complex.
I imagine sagas were hard
too at first.
Yeah, but not as hard as the observables are for me for some reason. I think that of all things concerning programming, I think for some reason those observables have always been like hard for me. I don't even know why. But I think that this way of doing just makes more sense to me personally for some reason. Nothing more? Well, you can always come and talk to me about this stuff later on. I think that it's impossible to like, of course, to handle in 30 minutes time, but go there, use them.
Let's wait for the video guy.
Okay, go ahead.
Okay, I hope this is okay to the video guy as well. But anyway, there's been like slight changes on the plan. So let's do kind of a minimal 10. Is 10 minutes enough? Yeah. Okay, 10 minutes break. So, yeah, take something and let's be back in 10 minutes. button, and whenever the video guy is ready, we will do this thing. Go ahead. All right. So hello everybody. How are you guys doing so far? Woo. Come on, how are you guys doing? Great. Yeah. All right. So yeah, let's get the energy levels up a bit. So what I'm here to talk to you guys about is building complex UIs. And as we know, we are building more and more web applications, we are managing more and more state in the browser or in mobile apps. Previously, that heavy lifting was for the large part done by the backend. Nowadays, you need to build it all yourself. Luckily, there are great solutions for state management, such as Redux. How many of you guys are using Redux in your work? All right, so you basically are using state charts to some extent, basically really a subset of that, subset of features of that. So, however, even with Redux, you still sometimes end up with code like this. Have you guys ever written anything like that? So basically, you have all those flags in your Redux or React state or wherever you're keeping your state, and then you need to do this really crazy shit in your render method. Basically going, is valid, is editable. Can anybody understand what's going on here? Well, it's really hard, and that's okay, because humans are not made to understand things from flags and binary values, zeros and ones. So humans are made to understand concepts, interrelations, things that how the world works. Something can happen here and it leads to transition here. So states are the building blocks that are really easy to think about and use. So this same code can be written with something like this. So this is a state chart. It's something you can draw, but it's also something you can code. So to code that, you merely need to define all the relations that are there. And the relations can be defined with plain and simple JSON. So looking at this graph, you immediately get a sense of what states the system can be in. And so I actually learned about state charts not too long ago, but apparently state charts have been used for ages. They've been invented in something like 60s or something, and they've been used in computer science for a long time, especially in electronics and programming circuit boards. It's pretty often common to use state charts there. However, how many of you guys have used state charts so far? One. Well, that's great. Two. Okay, awesome.
Program without this stuff in your head.
Yes.
Yeah, that's basically what you do.
Exactly. So you basically imagine this in your head, and then you try to translate into flags, right? If is this, is that, right? So when I heard about state charts, I started experimenting. We were working at that time with integrating actually a Bluetooth device, and apparently programming Bluetooth is really hard. You know, how many of you have had some Bluetooth problems in your life? Why are you guys laughing? It's not funny. You know why the reason is? The reason is because this has so many different states that it can be in. It can be in a state where it needs to be initialized. Then it needs to be in a connecting state and scanning state. It needs to find something. Then it can be in a connecting state when you start connecting to a device. And managing all that flow, how we traditionally do that is that we use some flags there, but we really push it towards the user. We say like, hey, user, you decide. Here's the flag, here's the spinner. Okay, now connect. Press the connect button. Why can't we press the connect button for the user? No, because the complexity is killing us. So we started with flags ourselves with this thing, and it didn't work. So eventually we started using state charts for managing Bluetooth connectivity to devices. But nowadays we are also using it for many other things, including some complex UI components. So here's another example of a state chart where you basically have two parallel possible states,
So these can be enabled at the same time. You can have this upper one and the lower one. And in the lower one, you can be in one of the boxes. If you are here, you can still have, you know, some variance there. However, if you're here, that doesn't read. You can't read valid or invalid. It just doesn't exist because you're in unchanged. So in using state chart, all these things become explicit. So in the previous example, how do you know that is valid and is editable and is modified are all at the same, can be used at the same time? Like oftentimes the errors in our code result from unimaginable states that we haven't thought about, but they exist because we pressed the button and some flag turned something, but we didn't think about that state. So state charts help you solve that by making it very explicit what are the possible states in the system and making it explicit what are the transitions happening between the states. So here I'm going to do a simple demo that for all of you is pretty familiar probably. So I have a simple form here, but with forms you all know that we have many things to worry about. So when we input a form, say I inputted a phone number, we need to manage basically, we need to show that, hey, there was an error with that field, right? Or if we don't have anything there, we want to disable the save button so that it's clear that, hey, there's nothing you can save. Or if you input a number there, you have a saving state, so it's saving somewhere, and then you have an error state, so you basically show an error. So it pretty quickly becomes fairly complex to think about these things. And how this is now solved here is by using a state chart. So, so state charts in JS, there are several great libraries you can use, but one of my favorites is XState. XState is basically, it gives you a way to model your state using pure JSON, and then you can pass previous state, an event, and then you get the new state. And also, if you want to do any actions when leaving or entering a state, it's going to give you all the actions you need to execute. So it's a pure function, basically. So it's similar to Redux in a sense. It takes current state, events, which are in Redux called actions, but whatever, and it ends up with a new state and actions to execute. So here in XState, I can basically, when I'm modeling this, I could basically model this whole thing in my browser, just writing this JSON and seeing like, hey, is all the building blocks there? I can also, of course, draw it, but by modeling it here, I can easily then transport that into my code and immediately use it to power my logic. So here, for example, it's the same form. So initial state is in editing state, and displaying state is off. You can see clearly that you have a form, an error. Those are parallel states in the editing state. So only in editing error can happen. Otherwise, error doesn't matter because you're in displaying state. It's just displaying whatever content there is.
Can you zoom in a bit?
Let's try. OK, well, maybe it's better a bit.
You also do more zooming now.
Let's try. All right, so if you look, for example, for the form state only, you can see that it can be in several states when you're in editing state. It can be in accepting input, submitting, and submitted. And in XState, you can also use timers, so it automatically integrates a timer. So after 3 seconds, it's going to go to next transition. Let's see why it doesn't show here. All right, there you go. Yeah, so here you can see also the transitions here. I'm going to zoom. Oh, OK. Maybe this doesn't work with the zoom. Let's try that. OK, how about now? OK, so in accepting state, you can basically have a submit function, which go to submitting state. After submitting, you go to submitted state, which shows you, hey, this has been saved, all good. And then it transitions back to displaying state, so non-editable state. And here you can nicely play around with this. So I can directly type in input, for example, and I can send that event, and now what it did, it saved it into a context, so I can press submit. And I have I have a condition here that it only can go there if the context is filled, if there's something in the input field. From here I can go forward to trying to, it's in submitting state, so I can go into submitting. Now it goes through the 3-second delay and goes into displaying state. And from displaying state, you can then go back into the initial state. And it again just enters this state, and you basically have only those states available that you have mapped in your tree. You can't have any race conditions here. And that's pretty cool. That's the single largest reason for bugs in the code. And the cool part is that you can easily play around with this in the graphical user interface. If you have a problem, you can debug it there. And yeah. So this is an example that you're probably more familiar with. Now, let's see, what else do I have here? Okay, I'm going to show you another demo. So let's see if that works. So, okay, so this is our app. So our app is, we are an online clinic treating depression, burnout, and anxiety. And we have an online program that people go through, and they learn certain skills and get better. And we measure results and outcomes of each patient that goes through our program. But the cool part here is that down below there's a mood diary. So I can basically enter a mood for today, and it's going to ask me some questions, and I can cancel that and go back to initial state. Or I can enter the mood. Again, it asks me some questions. By typing here something, it's going to have a save button there. You can see it over there. So now it's saved, and it shows me all the moods that I have logged so far. So pretty simple user interface, but still quite many small details, transitions, interactions, buttons that show or don't show, and so on and so forth. So let's look now together at how this looks like in a state chart. And it easily looks a bit complex from the outset when you just started looking at it, but actually it's really simple. So you are initially in a started state, and you have only one event that can fire. The good part with state machines that you have modeled all the states and all the events that can happen and lead to a transition. So if any other event like cancel or save or error or whatever would happen, nobody would care, because we are only listening to select mood event. So let's see. Okay. So I'm going to select happy mood there. And now by selecting happy mood, we have a transition there. So as you maybe saw here in the demo, the smiley travels to the left. So it flies from right to left. So you need to do the transition somehow have a separate state for that. So there is a separate state that's only 300 milliseconds, but then it goes into write comment state. And initially it's empty, and you can cancel while it's empty. You can go back to starting state. Again, let's try again. Select it. Okay, it's empty. Now let's fill it with something. Okay. So we typed there something, and now it's saved also in our context. So we can go into save state. We have the save button available there. There. Now it's in a saving state. You're still doing the API request. It can return you errors, so you can go back to the state you were in, like that. And it's still filled. It didn't lose the context, so it's all there. Now I'll try it again, and now let's go to success. And now it's in a success state, so it has two small transitions. First, it animates, shows you, hey, we saved, all good. Next, it opens up the diary feed, like this. Let's see. And I save that, and it opens automatically that. And in the background, it transitions back to the initial starting state. So this is an example where all the logic can be easily modeled with this JSON basically. You can play around with it. You can even write tests for it because it's all deterministic. And then it's a piece of cake to code from that because you basically coded all the complex parts, all the logic with your JSON. All right. Are you guys excited? What do you think? No. Yay. All right. Let's see what else we have here. So here's another thing we're building on right now. So this is a meditation player, and we have different functionality here. And with this example, if we hadn't started using state machines in our development, we would have said, hey, forget about it. Let's just make another button for the user to click, and let's have the user decide what to do next. But by using state machines, we can model very complex things in a clear manner. So here, for example, we have a meditation, which is, for the user, it's a fluent experience. It's just starting from somewhere and going somewhere. But actually, on the background, there are 3 tapes that are playing consequently, serially. So you start with introduction tape, then you go to practice state, and then you go to conclusion state. And all of that needs to happen automatically with internet connection. So you basically need to start preloading the next track while the previous track is already still playing. So we also have opportunity for the user to skip the introduction if he has listened to that already before, so he can just press that. There's a UI, so I can tap on the screen and it removes all the controls from there. And lastly, when it goes to the end, it can have this conclusion. You can play the conclusion, or it can automatically play it if you haven't played it before. And in that case, it would have a button which would say, hey, cancel, like don't play conclusion. And the last state is basically we are not playing anything there, but we just have a timer going. So if a person is still meditating, he can log his time even from that personal meditation. So as you can see, there are like a lot of pieces in this UI. And I'm going to show you. I've broken it down to a few. So first one is player. So the player itself can have several states. It can be playing or paused or buffering or have an error. That's the error, you know, like, okay, just press a button, try again. We need to have that because, you know, there can be loss of internet connection or something like that. So something that user can actually do that we can't do without him. And after that, he can also go to retrying state, which basically resets everything and tries to load the MP3 file again. So here, we have coded it so that playing is only playing as long as it receives the second, the basically ticks from the clock. So the ticks from the clock come 3 times a second. So it's all the time doing like this. As long as it's doing like that, it's going to stay in the playing state. So I'm here pressing the progress button with less than 2 seconds, and it's all the time staying in the playing state. Now let's see if I stop pressing that button. So it automatically goes into buffering state. And I can show a spinner there show that, hey, something's going on. If it starts playing again, it goes back to playing state. But if nothing happens for 10 seconds here, it's going to go to error. There you go. So now we're going to present the user an error saying like, hey, try this again. And he can press it again, retry, and go to again playing state. So this is the player part of it. And at the same time, we also have a logic for all the different tracks that can be playing. So initially when it starts from so-called transient states. So it basically decides whether to go into intro or practice. And depending on certain conditions, it's, for example, if there's introduction at all, it's going to go to intro. And there you have, again, fairly simple logic. So it can either have an event skip, so a person wanted to press the button and skips the intro, so it goes directly into practice. Or he can cancel the skip after, you know, like how if you do something irreversible in the UI, that's usually a bad pattern. So the best way to design stuff is so that a person can make an error, realize that he made an error, and go back. So this is what we're using here. So first we have an intro practice playing. Say a person says, hey, what is this button? What if I press the skip button? What's going to happen? It goes into practice state, but we still leave the opportunity for him for a few seconds to go back. So by cancel skip, he goes back to intro. And if the track ends, it's going to again go to the practice, and at the end, it's going to go to outro, and finally to overtime. And in overtime, it actually even has an internal timer. So if I would look at the state here, let's see if I can do that. So you can see that track time in seconds, it's increasing over there. So it's automatically doing a timer. So I basically modeled all my complex logic, all the timers, set timeouts, set intervals, whatever you use there, with pure JSON. I can test this, I can simulate it myself, and then when I integrate this into code, it's really easy because I already have like, hey, show this, do that. That's it. Cool. So final word, we recently, since we are getting patients from real, from doctors, from companies, from large companies, different organization. So we run into a problem where, okay, this doesn't show really well, but basically we have really different sign-up flows for different patients. Some patients only enter one form, and other patients enters 3 forms, and we send them reminders about the consequent forms and so on. And those processes are really difficult to combine and unify. And the reason for that is because all the businesses work differently. So we need to serve each business with their process, whatever process works with their business. So what we are now arriving to is basically using a state machine to model user signups and email reminders and all of these things. So basically, we're going to have a state, we're going to store it with the patient, and then we're going to do actions that are prescribed by his personal schedule. So with that, I want to thank you all for listening, and I hope you guys got a bit inspired to try this out in your projects. I think this is going to revolutionize front-end and UX and UI design in the future, because it basically creates all of these difficult things really easy and fun to build. And lastly, we are Meru Health. We're hiring developers. So if you want to apply, go to meruhealth.com/jobs and come work for us. Thank you. Oh yeah, questions?
Have you done like real projects with that? Like, have you actually implemented that state machine to Meru Health or whatever?
Yes. So, like I said, our Bluetooth connectivity is done with that. Our mood diary, which I just showed you on the app. Let's see if I can show it again. So this one is completely done with state machines. And we are now implementing this email scheduling logic in there and building this meditation player with that. So yes, answer is totally yes.
Like for how long you have used it?
For about a year.
For a year?
Yes. Pretty new thing for me.
Could you talk a little bit more about the process that you use? Like, for example, are you creating these state machines like in the design and estimation process of features? And what's the end result? Is it used in documentation? or is it kind of a throwaway at the end of the feature build out?
So these state machines are great for using in production to power your interactions. So it's not a throwaway for sure. That's like we as the developers, we use it for powering whatever happens there, whatever is the next thing that happens in the user flow. However, we found recently that by modeling these states with these state machines, it's kind of really easy to communicate with designers because they understand immediately, hey, okay, you've handled this thing, you handled that thing, so I basically need to design my whatever UI such that it incorporates those things that you have there. So we haven't yet so much used it. So far it's been mostly in the development team, but I think in the future we're going to use it more with design. Designers really think actually the same way. So they do the same drawings like I showed you before. They do the same drawings on a paper, napkins and whatnot, or whiteboards to model whatever user might be experiencing. What's the user flow? So this is basically a user flow explained. Yeah.
You were mentioning there are other libraries too, like this state. So you like this one, but can you name few?
Actually, I'm not familiar with others. I haven't tried them, so I would be really bad at judging. I know this one is really popular, but there are probably good ones. State machine as a concept is not so difficult per se actually to implement, even like in a simplest form. You can basically write it yourself. It's nothing fancy. But these libraries add you timers and actions, and they execute the actions and do all kinds of stuff for you. So that's what Xstate is cool, where I can use those timers and model the timer UI, for example.
So do you then like use this Xstate instead of the whole Redux, for example? Do you use it for all of the state management?
Good question. So I think like Redux still has a lot of places, and especially for sharing state between different parts of applications, Redux is a way to go. I could even use state machine together with Redux if I wanted to share some state across the application. For that, I would use probably Redux. But what Redux doesn't provide you, it doesn't provide you constraints between these different states and configurations you can have. And state machine does that, so it's a different thing that it solves. Oftentimes when we code, for example, say that mood diary, which I showed you, so it doesn't make sense. It doesn't make sense to model this mood diary in Redux state. Why? Because all the interactions happen locally in the components. And basically sharing that state somewhere, it's no use. It basically just complicates your UI. So we are here, for example, using state machine just in the UI part powering this component. And when we save stuff, for example, we still use Redux to render it in the state.
So since we're having the side effect evening today, what are you using for the side effects in your application for the mental health?
So there are different side effects. So for example, we've used previously a lot Redux thunks, but we find that when we start using state machines there, sometimes we can replace using of Redux thunks with just functions that we call from there and emit events. So basically, maybe you're familiar with having container components and whatever, dummy components or whatever you want to call them. So we oftentimes do that. If there's a state machine, we might do API calls directly in the container component. Or we might use a Redux thunk to fire that if it has any effect elsewhere in the application. Oftentimes it has, and that's why we use it. But yeah, we are still, I think, searching a bit of the best way to use it. Oh, there's the one.
Yeah, so Xstate, it basically saves all the configuration in JSON. Is the JSON actually readable, or do you really need to visualize it with some tool to understand what the hell is going on?
It's readable. It basically describes all of these arrows and nodes that you have there. So all of these transitions and events that happen, you just describe it with JSON. So for example, I can show you directly. Here's that form JSON. So we had, I'm not sure you can see so far. Yeah, let's try that.
You can see that it's huge.
Yeah, it easily expands because it's JSON. So it has a row for each value. So.
The airplane is connected.
Oh, okay. Oh well. Well. Well, the point is, yes, it's fairly readable. It's really easy to understand what's happening from which place, even without that visualization. But visualization does help, because you basically oftentimes think through the visualization yourself anyway. Cool. Thank you.
Okay, so next up is the next presentation. We won't have a break this time because we had it between the last speech. But anyway, we will take a couple of minutes to set it up. But don't go anywhere because, like, you know, it will be hard to get you back.
Oh, what show?
People, let's get ready for the next presentation, please. So, yeah, I don't know what to say, but anyway, sorry, it's been kind of a hell of a day, but don't worry about it. Anyway, the next presentation, very soon.
Say a few words.
Yeah.
Hello, can you hear me?
No. Yeah.
No.
No. Yeah, there's no speaker just for the stream.
Yeah.
So you will have to speak loudly enough for everyone. Yeah.
If I speak like this, can you hear me?
No.
Kind of. It doesn't matter.
Okay.
Okay, it's fine. So let's start.
Okay.
Go ahead.
For the video. I'm not used to these technical things. All right, are we good? Are we on air? All right. Hello, everyone. My name is Farzad Yousef Zadeh, but since my last name is pretty long, you can just call me Farzad YZ. And you can read more about me on farzadyz.com if that ever interests you. Before I start and pretty much spoil the whole topic, I want to say that, as my good friend Christer mentioned, it's the United States of Finland tonight because everyone was talking about the states suddenly. And the last talk, the previous talk was, I think it's personally pretty interesting topic. And I gave a talk about it last week on another React meetup that we have. It's more in detail about the complexity of user interfaces and where the hell is we're doing everything wrong and what's the possible solution. It mentions state charts and state machine at some point. So the organizers of this meetup were kind enough to give me another slot for next session of this very meetup. So I'll be giving the same talk again because there were some positive feedback. So if you're interested, please join. Tonight I'm going to talk about Redux Observables. If you got the joke of regular expression, this is the best regular expression I've ever written. And well, I had to test it for half an hour because I want to talk about observables and Redux Observables, so it's like a greedy optional thing. Yeah. Just a bit of a note. Since everyone talked about state tonight, I wanted to add something that there is no point of having fights because we are experts of fighting over topics in the ecosystem, especially in JavaScript ecosystem. And I think that, well, if you want to consider different options, there are a lot of ways, and probably all these toolings can be integrated into each other. So please don't fight. Just use whatever makes sense for you. And don't be selfish. You're not the solo legion of your project. Probably at some point someone else will join. So consider other people too. Tonight, I'm going to talk about Redux Observable. And as I said, you can call me Farzad YZ. It's not Uz, it's not Finnish. And I'm a senior software engineer, like to call myself senior, at Futurist. Of course, we are hiring. Everyone is hiring. So if you think that I'm a good speaker and I can increase the interest in Futurist, please join us. I'm usually talking about JavaScript, TypeScript, all the good stuff around that, React, and whatever. You can see it here, probably more things. You can find me on Twitter all the time. I'm not working at all. So I'm just tweeting everything that comes to my mind. Please, if you want, follow me. And well, the second social network, my favorite social network, is GitHub. So please check it out. The link to the previous talk, if you are interested in checking that beforehand, is deployed at state chart-driven UI development.netlify. Please check it out. This is also deployed, so don't rush into it. So before I start talking about observables, as some people said that it's very hard, and I agree. What is Redux, you may ask? Is there anyone that didn't use Redux? I didn't see the votes. Is there anyone that haven't used Redux at all here? OK, cool. Thank you. So as the official documentation of Redux states, Redux is a deterministic way to contain the state. And the reason that I'm using the word contain is that there's state and managing the state. And that is why you can use the Albertstock about state machines, because that is another layer. And there is an interpreter layer that you can use all this good stuff with the state machines. Redux is based on Flux architecture that is born inside Facebook and promotes the unidirectional data transmission flow, whatever, in the client applications, meaning that it's very different from whatever we used in AngularJS 5 years ago, that everything could update everything in a two-way data binding way. So everything is just like unidirectional, and everything is working as a functional state and whatever. Don't get into that. And there are some citizens in the Redux ecosystem, like actions, that are basically simple JavaScript objects with a string of type, which is a unique identifier. And there are reducers that are pure functions that always receive the state and the action, and based on the type of the action, they might update some chunk of the state that they're responsible for, or might not. We don't know. There are different conditions. And there are middlewares. If you haven't used middlewares enough, which we all do, well, I'm going to talk about it tonight. And what middleware does is that it basically is a function, is a curate function that receives a store, then the next, and the action. What the next here means is that, well, look, I think I have a diagram. Yeah, this is how Redux works. Okay. The thing is, we have middlewares, we have reducers that are just pure functions, as I said. And whenever you dispatch an action in your application, it first goes to the chain of the middlewares that are composable into each other, and then pass from one to the another. And at the end, the last next function, which is the same store dispatch function that we all know, goes to the reducer. So why the hell Redux team decided to put middlewares in the architecture? Because without the middlewares, it's pretty hard to manage everything. It's because middlewares are somehow responsible for many things, like logging any sort of side effects, like, I don't know, like timers, manipulating actions on the fly, probably modifying them, or decorating actions, or I don't know, like action orchestration, which I'm going to get to it later. And there are many other reasons that why we need to use Redux middlewares. For example, like encapsulating imperative implementations, or many other reasons that I don't remember right now, but we'll get to that later. But the problem with Redux is that, which you really will realize that very, very soon when you work with Redux, and that is, if you want to model everything in Redux, especially with all the complicated user interfaces that we use these days, there is a very, very critical problem with that, and that is there is no built-in solution for handling asynchrony in Redux. And probably they didn't want to get into that because that's freaking hard, I guess. And they let all the community that based on the context, they could just come up with different solutions. And that is the reason that we fight over this. There are different ways to manage asynchronous in Redux. And they're all like implemented as custom middlewares. And the first one is Redux Func, which is just a closure concept in JavaScript, meaning that since everything requires to be very synchronous in Redux, meaning that reducers in Redux are expecting synchronous action objects from you. So it means that if you're using set interval or set timeout or any sort of promise, you wouldn't go anything. It would be ignored. That is why we have Redux Func, which means that it lets your action creators to dispatch something rather than just simple JavaScript objects, simple actions. They can be able to return function, and that is the first primitive way we used to manage the whole asynchrony in JavaScript, callbacks, right? Function, return function is a callback. And there is a very, very bad problem with that, is that because we want to model a complicated user interface, a business logic, callbacks soon start to be messy. Everyone have heard of callback hell, right? Well, there you go. There's another way to do that, and that is promise. There are a bunch of good middlewares in the open source system for managing promises. For instance, you could like Saga, I guess. You could pass promise payload. If I got that. Yeah.
Works like that.
Oh yeah.
You can just like make the payload be a promise and it just in the background.
Yeah, that is too much magic to me, but there are different tastes. I'm not really fighting over this, and I'm just not trying to compare anything. I'm just trying to propose something. Feel free to search it out, look it up, and go with your common sense. And there are some middlewares that enable this ability for you to use promises, meaning that your action creators could also return promises. That is pretty handy. especially thunk and promise, but soon we need more complicated user interfaces. And you know that like product owners or other people are expecting to make the user interfaces even more complicated every day. So there should be a way to handle that. Another way is Saga. The word Saga is first, I think, came up from the Saga pattern, like some sort of academic article, I guess, 1987 or something. Look it up, please. And it advocates a process management pattern thing that lets you, instead of like having like one-to-one connection between some synchronous actions, instead have some sort of like interceptors that monitor the whole thing, and you can just like seamlessly dispatch different events and actions and then let something else take care of the business logic. And there are an alternative to these that are called observables. And observables are not really comparable to Saga, because Sagas are like a general name, some sort of like generic title for a pattern, but observable is actually a proposal for an entity, a primitive. They're on, I think, draft state or proposal state of TC39 right now, but they might land like 20 years later in the JavaScript standard library. But if you want to use them right now, you got to be learning RxJS, and they're like, it's a huge API surface. I don't even know how to work with that, but yet I'm talking about it. And but yeah, observables are here to let you handle different sort of complicated asynchronous stuff. Before that, can you really define what asynchronous means? Is there anyone here who could define it in like a paragraph or something? What does asynchronous mean? You're dealing with it every day.
It doesn't happen immediately.
True, but what does it mean? Like, how can you deduce that something is asynchronous and something is synchronous? If you want to use a solution for it, first we have to know what we're dealing with, right?
We need to put it off the main thread.
I didn't get that, but kudos. If you want to, like, I think asynchronous doesn't have a like definitive explanation, I guess, but if you somehow found a footprint of time dimension in something, or if you could somehow put the time freaking term inside the definition of something, that can be categorized as asynchronous. Meaning that if you're dealing with timers, for example, that can be asynchronous, right? If you're dealing with some streams, some pipelines that can be invoked multiple times, probably those are asynchronous too, because they're kept to wait. And I don't know, like input streams, like users unclick. Like when user clicks, it's actually asynchronous, but you deal with it in a synchronous way because all this asynchronous stuff is abstracted away by the React, right? Unclick is not synchronous. Or there are other things like every day, if you're like developing for DOM or developing for other platforms, you're dealing with a lot of event listeners in order to like message passing between different parts of your application, and those are also asynchronous. All right. Oh yeah, I missed that. Quick note, Saga middleware uses the generator functions. I think some people think that it's easier to get up and running with Saga, and they're probably right, because there's a huge API surface for RxJS, and in order to use Redux Observable, which is an integration between Redux and RxJS, or observables in general, you gotta first learn RxJS. I didn't do that. That was a huge mistake. Do it. Yeah, what is an observable? Well, if you want to define observable, it was really hard to look it up in Wikipedia or somewhere else, because if you look up observable in Wikipedia, some quantum physics concept will show up. Don't do that. Apparently, electrons, for example, in atoms are observables in physics. But in software development, observables are primitive entities that are push-based, meaning that you can push different sort of events into their pipeline by subscribing to them. And if you want to somehow see how helpful they are, probably I think the most like generous entity that we can use these days in JavaScript to deal with asynchronous is like promises. We can race between different sort of pipelines of promises. We can chain them. We can send parallel or, well, if you will, concurrent promises. And there are like a lot of good things about promises, but if you want to compare them to observables, there is a problem with promise, and that is that promises are not lazy evaluated. Meaning that when you instantiate a promise, when you create a new instance from a promise, it's already gone. Good luck controlling that. There is no way to pause it. There is no way to stop it. And every day you're doing your network requests in pure promises. So, well, probably we're using a huge amount of resource of our users. Food for thought. If you want to compare them, promises are not cancelable, as I said. And observables are cancellated because they consider the dimension of time. And promises are cached. Have you ever thought about it? Like, promises are not kept alive. It means that they're cached. Once you instantiate a promise, it, well, either fulfills to rejected or resolve the state. And once it's fulfilled, at last, whenever you call it again, you're going to get the same value. It means that it's cached. It's always represented as a single value. But it's not the same for observables, because observables are more like a pipeline of streams of data, if you want to like explain them in that way, meaning that they're always like a kept live connection, so that you could push different events in them and invoke them multiple times, and based on the past conditions, you might get different returned outputs. And promises are to some extent transformable, meaning that you can reduce them, you can like map them, or use whatever higher order function you want on them. Observable are the same, probably better. They're composable, meaning that you can, for example, merge different sort of stream pipelines together. Observable pipelines together. You can like zip them, or you can like concatenate them, whatever you want. Observables are, since they consider the dimension of time in their definitions, meaning that you can control them over time. So it's really easy to throttle them, to debounce them, or to delay them. Fairly easy and simple. And again, because they are lazily evaluated, it means that you can just retry them on demand or repeat them as much as you want. So as I mentioned before, Redux Observable is a custom middleware for you to integrate RxJS that is advocating reactive function programming paradigm with Redux. Well, I think I mentioned it, that Redux Thunk is technically able to be used at the same time with Observable and Saga. It's because you might encounter that somehow it's an overkill to use these middlewares, because they're optimized for a pretty complicated logic, business logic. So if you use them for like really simple asynchronous stuff, like just loaders and I don't know, like set timeouts and console log and stuff like that, it works perfectly, but it's an overkill and might not be as readable as you think. It's hard to grasp as knowledge. So it's technically okay to use Thunk with any of them, and use Thunk as much as it makes sense, then use them for complicated use cases. One thing to note here is that this is a chunk of the code base of Redux Observable. I got it from the GitHub today. I want to demonstrate that. Take a look at this line. This line says that this is like how middlewares worked. As I showed, there's a next, there's an up level that is store, and then there is next, and there is action, and whatever is here returned, it goes to the next middleware. And when you call next on the action, it evaluates the next state. So meaning that all the things that you use, all the pipelines or like whatever you use in the Redux Observable world, it's not swallowed somehow. All the actions will eventually reach the reducer, and they will reach reducer level before they reach the epic level. I'll get to the epics later. But meaning that whatever you do, keep that in mind, that your reducers are not somehow like ignoring. They're working the same way, because the way that the Redux Observable works is that it somehow instantiates a parallel channel to a stored dispatch channel, and somehow like intercepts and monitors different actions. And well, it does what it does after the reducer has updated the state. And there is a reason for that, because you want to have the most updated state in your epics. You're going to do the most critical business logic in your epics. So you're not going to deal with stale states, right? So there's a reason for that. And I wanted to show this because I want to demonstrate that based on the fact I'm telling this. This is the notation of using the first-class citizens of Redux Observable were called epics. Basically, putting into simple words, epics are, well, functions that receive an observable of action and an observable of the whole store, and an object of dependencies. I'll get back to that later. And it subscribes to sort of dispatch, meaning that, well, as I said, it mirrors the channel of a sort of dispatch, meaning that your actions will eventually reach reducer, and then epic would take care of that because of the update. So it's subscribed, so it's invoked, and you know. And the notation of like the typed version is that epics will receive an observable action, and these are like simple Redux actions. And there is your store. So everything, since it's in RxJS, everything is observable. So it's again observable of a store, and it always returns an observable of one action. But it doesn't mean that you're always dependent on one single action to be returned, because it's fairly simple to concatenate all the observables together. This is how you get to integrate Redux Observable into your current Redux code base. There are basically two things that you need from the Redux Observable library. There is combine epics that just works exactly the same as combine reducers work. The reason for existence of combine reducers is that you get to somehow distribute your different chunks of a state and the responsible part of reducer for that into different parts, and you get to like seamlessly use combine reducers, I'm sorry, because at the end a store can just see one root reducer. This is the same for combine epics, and the epic middleware is just going to see one epic at the end, but you can distribute it with combine epics. And there is a create epic middleware, which, well, if you have used Redux Logger before, is Redux Logger before. It's the same as that, because that also has like a factory called create Redux Logger or something, or create Logger. You get to like create a new middleware based on different past options to it. You create a new epic middleware. It's basically a new middleware of the Redux. You have your root epic, which is the combine epics of whatever epic you have in your app. You're going to probably import them like your reducers, combine them together. And then you create you instantiate, not instantiate because it's a factory. You create a new store, and that is like the store of Redux for your application. Pass the root reducer as usual, apply middleware. You pass the epic middleware because you want your epics to work on your actions, and then whatever you have else in your middlewares, just pass them normally. And at the end, after you created your store instance, you can just simply run epic middleware.run with your root epic. If you have taken a look at the first presentation's code, it's fairly the same as redux-saga. Like they're having the same exact API on this level. Some practical examples. If you want to do very, very simple side effects in Redux Observable, you create an epic. But as I said, it just gets a stream or observable of action. And you just basically, like, if this doesn't make sense to you, pretty okay. Because it's fairly RxJS. There's no like a new entity in Redux Observable besides the epics. So everything else, all the goodiest stuff and baddest stuff, comes from Rx world and all the reactive functional programming paradigm. So if you don't feel okay with this, it's pretty okay. Don't get frustrated with that. Well, you can pipe different sort of collection of utilities that whatever you want to do on your action. But the important thing is that you either have to ignore or you either have to dispatch, return an observable of an action at the end of the epic. So what it does is that it creates a pipeline on the received action. It filters based on the type because all the epics are listening to all the actions. So you probably want to do that. Quick note on that. If you don't handle the received action in your epics or somehow let that pass through or return the same action, it's going to create an infinite loop. Because basically you let it be able to reach the reducer, then epic gets it, then it again returns the same action, reducer, epic. Halting problem, I guess. That's the name. And that's why we have to do filtering at the first level all the time, because we want our epic to be responsible for just one action probably, or you can just like compose it for different actions, but probably it's better to extract different sort of business logic into different epics. And for doing side effects, you can just use tap from RxJS operators. You get the payload from the action, and you can do like window.alert or whatever you want, and then you ignore the elements. Another practical example of Redux Observable is that if you want to have automatic dispatchers, if you check out the official documentations of Redux Observable, there is an example of ping pong. And it means that if you, for example, want to like dispatch a ping action, and then you immediately want your opponent to dispatch the pong action responding to you, it is called automatic dispatching. And the pattern is called automatic dispatchers, and you probably want it a couple of times in your client applications. This is the way that we are used to do it in simple Redux. If you had Redux Func, for example. This is like show notification action that just returns an action object. Can everyone see this? Is it big enough?
Yeah.
No? I don't know if I can zoom this in. Well, it doesn't work on Google. It's fine. It returns a simple Redux action. Then you have a dismiss. Oh, I'm sorry. I didn't explain the whole thing. I wanted to say that although that's like a ping pong simple like example of what you have, but you can really easily relate that to some practical example in your user interface. So for example, if you want to have like automatic dismiss notifications, that for instance, if you want like to show the notification and automatically after 2 seconds dismiss it. You've seen it plenty of time, right? In a simple Redux Func architecture, you can have it as a simple action, then simple action for dismissing and showing, and there is an automatic dismiss notification that you can call it from your view layer, and it receives a func, and then dispatches show notification, and then with a set timeout of 2 seconds, dispatches dismiss. This is done. Pretty straightforward. In the Redux Observable world, you have the same action, but you have the yeah, I didn't create the action creator for dismiss, but it's pretty okay because it's just like simply returning the action object itself. You're going to have the same action creators, but you're going to have one epic to listen to that. So you want to have like show notification epic and then filter based on the show notification type because again, it receives all the actions. And you're going to like simply put a delay here, as simple as that, and then map it to dismiss notification. And in the dismiss notification epic, which listens to this action being dispatched, it just filters based on that and ignores it. And that is your combined epics because probably at the end you always want to return one epic. There is another one. I'm so sorry for this, but there was no better way to structure this. And I can't even zoom in on Google Slides, so blame Google, please. It's an example for debouncing the inputs of like a search box or whatever that your user is like seamlessly having problem with you writing in. So you want to debounce that, but I'm not a fan of debouncing on the view layer. Sorry.
Show a Rix pebble for debouncing.
Show what?
The pebble diagram for debouncing. That will be a good substitute.
Marbles.
Yeah.
I don't know how to look that up. From the next presentation.
Yeah, okay.
Thanks for the suggestion, by the way. For the debouncing input, you have a show query. For example, if you want like have a search box in your application, and you want to have an action to search for something, and then you want something to you want another action to dispatch. You want an action creator to dispatch an action to call the API endpoint to get the response for that search query, and you want to have an epic that listens for search query action, debounce time, again fairly simple, debounce it for 1 second, and maps it to search query from API. And search query from API, like maps it to this action, which is search query from API action. And then there is another epic that listens to dispatch of this action, filters based on the type of that, does a switch map, and does an AJAX, maps response to some action, and catches the error. And this is as simple as putting catch error block here in any nested level you want to handle the errors. I wanted to demonstrate that too. So in this example, although it's really long, but it's very straightforward to explain it. Meaning that if you want to have like a search input in your client application, you probably and you want to debounce it, you want to have 2 actions. The first one is searching, another one is getting the search query from API. And you want to have two different epics listening to dispatching of those actions. One of them is just responsible for dispatching to the first one, which is searching and debouncing, then maps it and passes it to another epic. And this epic just picks it up and does the AJAX one. Another example, I hope that this is better now. I got smart somehow in this part and just like put this chunk. It's called action orchestration. And that means that I've seen it in a lot of Redux code bases that people think that they have to dispatch one action and then that action just is received in the reducer level and that's it. There is not necessarily, there is no obligation for one-to-one connection. You can like, for abstracting away the complicated business logic, you can easily orchestrate your action. And this is not just for Redux Observable. It can be done in even simple synced way of Redux or Thunk or Saga or whatever that interests you. It's called action orchestration, this pattern, meaning that if you want to like log in a user in your application, you probably want to call an authorize that come from some service. And then you want to like persist the like token into some sort of storage. And then you want to dispatch login success because you want to signal the reducer, hey, it was successful. Please do some state update. And then you probably want to navigate, right? All of these, like for me, before I learned this pattern, all of this was distributed into different level. Probably this one was like some sort of lifecycle in React, and it was just doing it. I'm sure someone else did it too. I'm not the only one, probably. And like it's fairly easy if you have a reactive way to do stuff. It's fairly easy to orchestrate your actions. So your epic just sees one action, listens to login, and then everything else, all the business logic happens here. You don't even have to take care of that in your action level or reducer level, because reducers are supposed to be pure, right? Actions can have side effects, but I'm not a fan of that, because that means different parts of a single business logic should be distributed in a different way. So if I want to update something, I have to like search in the whole code base, hoping to find it somewhere, and probably some tests would catch it later. Or this is usually, I've seen it in a lot of code bases, that this is usually done in some sort of life cycle, and I did it a lot of times. But this is wrong, because this is fairly easy. If I want to log in, I just want to log in. I don't want to care about these. And on the catch error level, if you want to like catch the exceptions of these network requests here for authorization, you can catch the error because it's just a catch error block. You get the error, and again, you can orchestrate the error too, because you're not just going to show the notification to the user. You want to like do crash reporting. You probably want to do like analytics. I don't know. You want to like do I don't know, whatever you want to do, you can easily orchestrate in this way. And in case of loaders and indicators, you can like concat different chunks of operations and these utilities together with a concat. And as I said, they're like composable. Those are observables, right? So you can just concat them, do a loader enabling, showing some loader, deferring the whole AJAX because you want your disable loading to wait for the authorization. So you defer it. And you pipe it to here, handling the response, handling the catch error, and at the end, whatever happened, you don't care. You want to disable the loading. One of the things that is probably the primary reason why people even get interested in reactive programming is that it's fairly easy to cancel observables. How many of you have canceled like network requests, at least in the client application you develop? Chris, I know you did that because we use the same thing together. But is there anyone else that like thinks about cancellation on the network level? Like for instance, if I want to have like a search page, for example, if I want to develop like Netflix, and I want to like put a search page somewhere, and then I search something, but before the search response comes, I go to another route. What happens to a network request? Should we handle that? Should we use it? Should we just ignore it? Should we just hope that user has enough resource? Have you ever seen that different things are blocked in the UI level? There are some reasons for that. And that's because we're just like somehow ignoring all these. And these sort of toolings can help us at least think about that. There are two types of cancellations that are able to happen in the observable world. The first one is implicit cancellation, meaning that if you just use switch map, just use it. And like this switch map, if it's doing the search API, then if your user calls it again before the previous one being resolved or rejected, if it's pending and the second one comes, switch map would just cancel that in the network layer because AJAX is cancelable, and then just pick the last one and take care of that. So by using switch map on the network layer, you're implicitly doing the cancellation. But if you want it to be explicit, it's not always about the network. Somehow, if you're like changing the route, you want some pending thing or some pipeline to be like how do you call it? Destructed. You want to terminate some pipeline. You want to like terminate some sort of asynchronous task. So you can do explicit cancellation with explicitly signaling by the take until operator. But take until should always be on the last part of the chain in order to avoid the leak. And there's a good article for that. It's on the resources of the talk. And take until should be on the last step of the chain, and also it should be on the same level that you're doing some asynchronous stuff. So search query from API, if you want to cancel that explicitly, take until should be on the same level. If we want to fairly do a comparison between different paradigms or toolings or whatever approach you want to call them, we have to consider many aspects, because otherwise we would just rush into different solutions. And those aspects are the steep learning curve or easy learning curve, how easy it is to get on running and be like productive with something, the testing point, I don't know, like the coverage, this sort of stuff. So I thought that if I don't cover the testing part, it wouldn't be fair. If you want to test like a side effect with Redux Observable, the only things that you need to mock is the state and the action that you pass to the epic. Because at the end, epic is just a function that, as you remember, receives action, state, and an optional dependency object at the end. So you can just import these sort of goodies stuff from Observable for mocking. And not just for mocking, but you can use it for mocking. Create an observable of the action, whatever action you want to test the epic for it. And you create a mocked store for yourself. For example, I wanted to like mock transactions here and the login which has access token here. And I want to like pass them to the fetch transaction epic because I want to see how epic works. I want to test it. And I do a subscribe the same way that the middleware subscribe to the store dispatch. There are 3 different callbacks passed to the subscribe. The first one is the success one, the second one is the error one, and the third one is like basically the final block or the eventual thing that is fulfilled. So on the actions, all the actions that were dispatched by that epic are going to be available here. So it's as simple as doing a snapshot testing with jest. You don't even need to imperatively call them. You can just do a snapshot testing, and whenever your snapshot is updated for some unknown reason, like be aware of that. Thank you for your patience, but before I finish, you can check this talk online, redux-observable.netlify.com. That's a habit I grew and I grew it when I wanted to start talking, and I deploy it all the time. There are a bunch of resources. I'll probably update this and add them to the talk. And there's something else. Please always consider your team, yourself, and please consider that if you want to use Redux Observable, there is a huge, steep learning curve for RxJS because it's a huge shift of mindset. It advocates for reactive and functional programming. So and it has a huge API surface. There are a lot of like utilities in the API, in the standard library, if you will. And well, Redux Saga has been created before Redux Observable. So it means that it has a better community, but it doesn't mean that Redux Observable is not mature. So go with your common sense, compare, I can trust you. Look it up, and just don't look at one Medium article. Please do a good research on that. Thank you. Any questions?
Okay. Have you found that in production it abstracts complexity for you and like it helps you manage complexity, or?
I come from source code. I come from a place that we used to do source codes in somewhat not pretty ways, meaning that I was distributing my business logic into different life cycles, as I said multiple times, or like like different chunks of a single business logic was in actions and like some middleware, some reducer, some lifecycle or React component or whatever. And for me, using one epic to focus on a single chunk of business logic was a huge win. But at the same time, because I didn't know how RxJS worked and I wasn't familiar with the library, I was a bit like, it was a pain point for me. But then I got to know it a bit better. I still don't know. And it was better every day. But I got to thank my colleague Christer here, who helped me throughout the whole thing. And it's a really heavy architecture to carry on. But at the same time, if it makes sense for you and your team and the context of your project, it's a huge win. I hope that answered the question. Okay. Yeah, go on.
Have you been rewriting the existing code bases to the reactive stuff, or you've been doing only greenfield projects?
Technically, yes, because I used to think in a bad way. So in my mind, I had to rewrite that. But in the code level, no. Actually, I can't imagine how hard it would be. But there would be some like some bad parts and some edge cases, I guess. But if you know what you're doing and you know about the context of the project, probably you can refactor fairly easily. I don't know about that. I would be like happy to hear the feedbacks later on.
Yeah, it's just like my experience with observables was that probably the most powerful part is the composability, and it really like shines when you need to merge several event streams. For example, in imperative code, that would be like many lines, which would be just 3 or 4 in the Rx. I was kind of nudging you to talk about that point, but
well, yeah, but since I wanted to focus on the observable part integration with the Redux, I just like focus on that. But there are plenty of things to talk about Rx and the whole reactive functional form of like paradigm of programming. But I kind of wish that there was a way that you could integrate Rx data flows and pipelines with Redux DevTools. Like Cycle.js has this one. It has I think it has a DevTools extension that you can install, like React DevTools and Redux, and it shows you the whole pipeline, signaling and highlighting different parts of the state that are being updated and all these like epic things that are being called. But I don't know whether RxJS has it or not, but I didn't find anything yet.
Can you you mentioned the issues that arise from not canceling things, and not managing those cancellations on the network level. Can you describe like concretely the instance where you found that was a
race condition? I searched for,
but like at a user level, like at what point in your process in developing with React and Redux would you start to notice that? How would it manifest itself in terms of user interaction? Is that in like flame graphs, or like what does that look like when you're not doing that? Right?
I'm just used to monitor everything in the network panel of Chrome DevTools. Yeah. That's it. Like we were using this on a React Native application, and there was a like hacky way to use network panel of Chrome DevTools with React Native, and well, I just monitored that, and well, a lot of bugs raised from just monitoring that simply. But if there is a better way, please share it.
No, I'm curious. I had never thought of it before. So
probably that's like a topic you can develop an open source tool for that. Okay, I think. Yeah. Well, I'll appreciate it.
Just quickly to add, for example, if you have a large file, you're uploading it, you don't want to keep that uploading till the eternity, even if you cancel the request, right? So those instances.
Okay.
Yeah. Thanks.
Yeah, I was kind of wanting to continue on the last question, because last I checked, granted I haven't checked in a while, but Fetch doesn't support canceling requests.
Of course, and that's because RxJS Ajax operator does like uses XHR under the hood. That's why you can get like an abortion cancellation token from it and then cancel it. No, you can't cancel a promise. Even with using all these utilities, if you're using an entity of promise passed to that defer, you can't still be able to cancel that because you can't do magic.
Fetch doesn't support canceling the request.
That is true. Yes.
So basically, the request goes to the end either way, but you can fake it.
But you can always use XHR, right?
No, it uses Ajax instead of fetch. It doesn't use fetch on the lowest level, so it's a different thing.
Any other questions?
You mentioned about edge cases and where complexity arises. Can you mention any that you found in your work?
Yeah. Like one of the most complicated things was we were using an implementation of OAuth 2 standard, and we wanted to do refresh tokens. That was fairly hard because we wanted to like remember what we were doing. If it was like hitting an unauthorized, do the refresh token, then somehow remember what we're doing and continuing that. We still haven't implemented that. It's on proposal level for us, but it would be like the most complicated use case I've ever seen. Yeah. So, thank you.
Okay, so for the rest of till whatever time.
More pizza.
There is more pizza coming, and then but anyway, we actually have a sauna there, which is actually already properly heated up, and
there are towels.
There is towels and everything, so you don't have to bring anything inside. So just go to sauna, have fun. There is drinks, there is pizza, there is everything. So just keep hanging around until we say we don't want you anymore.